Hello everyone. In this lesson, we are going to do the same thing as last lesson, except we're going to talk about the converse theorems. So, for example, for the alternate interior angles theorem, it says that if two lines are parallel and cut by a transversal, then the alternate interior angles are true, or are congruent. So the converse would be the opposite of that. So if the alternate interior angles are congruent when you have two lines cut by a transversal, then those lines are parallel. So it's the same thing with the other two theorems that we learned about yesterday. And you've already actually seen an example of a paragraph proof. So I just wanted to mention this real quick. A paragraph proof is the same thing as a two-column proof. It's just written in sentences. So a two-column proof written in sentences. So you've already actually done one of these, if you can remember which one it was, where you had to drag and drop different statements and reasons into the paragraph, and you'll see more of them in the future, as well as flow proofs. We'll talk about those later. So the corresponding angles converse postulate, or corresponding angles postulate converse, says that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. And you do have to remember the difference between the converse and the original. So here, for example, find the value of x. This is an example of how you would see the converse. So find the value of x that makes line M parallel to line N. So over here, these are corresponding angles. So if the corresponding angles are congruent, then the lines are parallel. So if we set them equal to each other, because it's saying to find the value of x so that they're parallel. Okay, and then we just solve for x. So this would be 68 over 2 is 34. Okay, so that's pretty easy examples. Okay, and then the opposite are true for the other theorems. So if two lines are cut by a transversal so that the alternate interior angles, exterior angles, and consecutive interior angles are congruent and supplementary, then the lines are parallel. Okay, so just pause the video here and make sure to just write all this down. You can actually just copy down one diagram. So here, and then just label the different angles with the numbers. So here we're talking about angle 4 congruent to angle 5. Here we're talking about angle 1 congruent to angle 8. And here for supplementary, we're talking about the measure of angle 3 plus the measure of angle 5 equals 180 degrees. Okay? So let's do a couple more examples with this. So here's an example of flags. So here's the transversal. Here are the two lines that are cut by a transversal. Notice that in the diagram, there's nothing that says that these two lines are parallel. So you can't use the original alternate interior angles theorem. Instead, you're going to use the converse, because what you do know is that the alternate interior angles are congruent. So by the converse theorem, you know if the alternate interior angles are congruent, then the lines are parallel. The lines formed with the transversal are parallel, or that form the alternate interior angles. So how can you tell whether the sides of the flag of Naples are parallel? Well, it's because, if angle, we'll call this 1 and 2, if angle 1 is congruent to angle 2, actually, hold on a second, erase that. We're just going to say the theorem that we're talking about. That's really all you need to say here. So by the alternate interior angles converse theorem, or you can use THM for theorem. So how about these ones? Can you prove that A and B are parallel? Explain why or why not. So here, what do you think? This would be yes, because alternate exterior angles are congruent. So by the alternate exterior angles converse theorem. How about number 4? This would be yes, by the corresponding angles converse postulate. So corresponding angles converse postulate. So therefore, line A is parallel to line B, and the same thing here. So notice it does not marked parallel, but since we know that the corresponding angles are congruent, then by the converse postulate, we can say the lines are parallel. Here, measure of angle 1 and 2 are supplementary. Well, those are alternate interior angles. Alternate interior angles are supposed to be congruent in order for lines to be parallel. It's the consecutive interior angles. So, for example, if 2 is right here, then we could say yes. But right now, we can't. So this would be no, and then because the consecutive interior angles are not supplementary. All right. Let's look at a proof. So it says in the figure, line A is parallel to line B. Okay, so let's go ahead and mark that since it's not marked already. So A parallel to B. And angle 1 is congruent to angle 3. So let's mark that as well. Angle 1 congruent to angle 3. Prove that x and y are congruent. So one thing I want you to notice, are angles 1 and 3 alternate exterior angles? Think about it. Are they alternate exterior angles? So the answer is no, because they don't share a common transversal. So the transversal for angle 1 would be line B, the transversal for angle 3 would be line A. 2 and 3 are alternate exterior angles, but 1 and 3 are not. So even if 1 and 3 are congruent, we can't say that line X and Y are parallel quite yet because we need them to be alternate exterior. All right, so let's write a proof. Your proof has 5 steps in it. So if you want, you can number the steps. But first, let's just say our givens, and our givens are just going to go on 2 steps. So first, A parallel to B, and then next, angle 1 is congruent to angle 3. Given and given. You don't always have to write your givens in the first 2 steps, but if you're not really sure, then just go ahead and put them in the first 2 steps. So let's first work with the fact that line A is parallel to line B. So if line A and B are parallel, then what can you say about angles 1 and 2? Well, they are congruent because they are corresponding angles. So let's say angle 1 is congruent to angle 2 and this is the regular corresponding angles postulate, not the inverse. Corresponding angles postulate says that if 2 lines are parallel and cut by a transversal, which they are, then the corresponding angles are congruent. So now we know angle 1 and 2 are congruent. Okay, and then I said there were 5 steps. And on the 5th step, we want to say that X is parallel to line Y. So you can go ahead and put that there. So what could we say for step 4? Well, look at 2 and 3. We can take the fact that angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2, and say that angle 2 is congruent to angle 3 by transitive property, skipping the middle. So if line X is parallel to line Y, we use then those would be alternate exterior angles, and that'd be the converse. So if the alternate exterior angles are congruent, then lines are parallel. So alternate exterior angles converse theorem. Okay, so it's as simple as that. So let's now talk about the transitive property of parallel lines. So this is an interesting one, and it's pretty obvious, but it does have a transitive property does have a specific property for parallel lines. So if two lines are parallel to the same line, then they are parallel to each other. So for example, if P and Q are parallel, and if Q and R are parallel, then P and R are parallel. Okay, and here's just a classic example. We're not going to go through it, but basically, each utility pole shown is parallel to the pole immediately to the right. Explain why the left pole, this one, is parallel to this one, and that's by just the transitive property of parallel lines. So if this is parallel to that, that's parallel to that, blah, 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 then T1 is parallel to T6. Okay, and then let's do maybe just a few more examples, and then the rest will just be in your assignment for Edulastic. So find the value of x that makes line M parallel to line N. So we're given two angles, this one and that one. They are consecutive interior angles, and they are supplementary. Well, if we want line M and N to be parallel, then these two angles have to be supplementary. So 3x minus 15 plus 150 equals 180. So this would be 3x plus 135, because this is negative 15. 3x equals 45, so x is 9. On this one, can you prove that lines A and B are parallel? Why or why not? So if so, explain. Okay, well, this is 144 and this is 36. We don't know any angles over here. Since we don't know that any of these lines are parallel, we can't say anything about these angles here in relation to 144 and 36. If we can't say anything about these angles or these angles, then really you can't say too much about these over here. You do know that this is 144, but still, you don't know that A and B are parallel, so you can't say that this is 144 over here. You can't say that this is 144 over here. And since these 144s are not alternate exterior angles because they don't share a transversal, then you cannot prove that the lines are parallel. So we can write no, because you could just say because they don't share a transversal. They don't share transversal, and you don't have enough information. On the other angles of this vertex and that vertex. Okay, so that is it for now. The rest of the problems will be in your Edulastic assignment. Okay, have a great day.